So in this video, let's talk about the molecular, complete, and net ionic equations, okay? And we're going to look at two. We're going to look at precipitation reactions and acid-base chemistry. And again, this works for any types of reaction, combustion reactions, all that good stuff, okay? Now, before I start, I need to mention one thing here, okay? Elements, compounds in their natural state, we do not break up. So liquids and solids will leave as is. We don't ever break these up, okay? So the molecular equation, we know what the molecular equation is. It's given, it's given, it's given. We need to come up with the complete ionic equation and the net ionic equation. And what we're doing is that we're essentially taking this whole equation and breaking up into its complete ions, okay? And so with this, we got to be very good with our charges. So let's break this all up into the complete ionic equation. Okay, so let's say this happens to be our complete ionic equation. Okay, so if I look at this, well, I know chlorine has a negative charge. Well, this has a 2, so by our uncriss-cross rule, then SR has to have a 2 plus charge. Now, it has a 2 plus charge, so we know this is SR 2 plus, but what's the coefficient in front of it? Well, it's 3. So this would be 3 SR 2 plus chlorine minus, but look, we have 3 times 2, which will actually give us 6 Cl minus AQ, and we can't forget our subscripts here. So again, we have to multiply this 3 times this 2 here to give us this 6 chlorine, okay? And all we're doing is distributing the coefficients to the actual atoms themselves, okay? Now, if I look at this, well, phosphate is a polyatomic ion. And so in this case, 2 times 3 will actually give me 6 moles of lithium. So this is 6 lithium plus, this is aqueous, plus, well, phosphate is a polyatomic ion, and so we can't break this up. So we know this is PO4, 3 minus. Okay, in fact, we had 2. Okay, and this is aqueous. Okay, and we draw our line, and then we go over to all apart. Now be careful, this is a solid. Okay, so again, by this rule here, we don't break this up, so we're going to write it just as it is. So this is SR3 PO4 2, and that's a solid. We don't break that up, but we do break this one up, okay? And this is 6 lithium plus AQ plus Cl minus AQ, and we have 6 of those as well. Okay, so what we're doing is that we're distributing the coefficient to all the elements in the molecular formulas, and we need to be careful with their charges. Okay, so the only thing I'm doing here is crisscrossing. If you've watched my videos, you know that how we form these equations, that we crisscross by their charges, and how we take them apart, we just uncrisscross. So the 3 will come up in front of phosphorus, and then because this is a polyatomic ion, we have essentially a 1 here, but it's not shown, so this is lithium 1 plus. Okay, and it's the same thing for this. The 2 comes up, and Cl, we know chlorine is a halogen, so that's a -1, but the 2 comes up to give us SR2 plus, okay? And so in this case, this will actually be your complete ionic equation. Okay, now the net ionic equation, how would we do that? Net ionic equation. The net ionic equation, we pretty much have, we just need to cancel out what we call spectator ions. And so when we write in the net ionic equation, we look on either side of the equation what is uncommon. It's like a math problem. If we have 6 on one side and 6 on the other side, they eventually will cancel out. And so if I look at the equation, I see that I have 6 Cl over here on the left hand side. I have 6 Cl on the right hand side. So those go to 0. Those will cancel. Okay. I have 6 lithium plus, and I have 6 lithium plus on the right hand side and the left hand side. So these will also cancel. And because they will cancel, these are what we call spectator ions. Okay. They don't do anything in the solution, actually. They're just there to spectate or sit. Okay, and so essentially net ionic equation is whatever we have left. And so if I write this, this looks like to me I have 3 Sr2 plus aqueous plus 2 phosphate ions aqueous, and that will give us Sr3 PO4 2, which is a solid. And it should make sense, right? It should make sense. If we combine these two together, this will give us the desired product. Okay, so that's how we take the molecular equation and break it up into its substituent parts. Now let's take a look at acid-base chemistry, okay? We know an acid is a substance that produces H plus in solution. So hydrochloric acid, sulfuric acid, we get H plus in solution. Okay. Now base is the opposite. We get OH in solution. So sodium hydroxide, magnesium hydroxide, calcium hydroxide, those are all base. With this OH here, I'm going to get my OH here. Okay. Now the general form is that, and take this with you, is organic chemistry. Okay, guys. Acid plus a base will always give me water and salt. Okay. So here I'm given a molecular equation of hydrochloric acid and sodium hydroxide, and I'm asked to find the complete ionic equation and the molecular and the net ionic equation. So if I'm looking at the complete ionic equation, then, well, it seems to me as if I break this apart, I'm going to have H plus AQ plus Cl minus AQ plus sodium is in the first row, so we know this is a sodium plus AQ plus OH minus AQ. Okay, and then we simply just draw a line across, and that will give us sodium plus AQ, okay, plus Cl minus AQ. Well, this is in its natural state. This is water. Notice this is a liquid, so we don't touch this at all. So this is just H2O liquid, okay? And this will be the complete ionic equation. Now, if we want to write the net ionic equation, then we simply look for spectator ion. So notice that we have chlorine minus and chlorine minus on both sides. So these will cancel and go to 0, okay? We have sodium plus and sodium plus on the same side, so this will cancel and go to 0. Okay, and essentially it looks that we can't cancel anything first. It looks to me that I have H plus, okay, plus OH minus, and that will give me H2O liquid. And I forgot my subscripts here, so aqueous and aqueous. Okay, so this would be the net ionic equation. Okay, now here's what I want you to do. I want you to take this with you, okay? Any acid-base reaction will always give you water as a net ionic product. Any acid-base reaction, again, will always give you water as a net ionic product, okay? Any acid-base chemistry. So that's very important to know, okay? Okay. Let's take a look at one more. What if we did sulfuric acid, aqueous, and we added magnesium hydroxide, aqueous, okay, and that gives us 2 moles of H2O liquid plus the salt magnesium sulfate. Okay, this is the molecular equation. How would you write the molecular equation? So how would you write the complete ionic equation? Well, let's start. We know sulfate is a polyatomic ion, okay, so essentially we have 2 hydrogens, so this will give us 2 H plus AQ plus the sulfate, which is SO4. My 2 will now come on the top. My 2 from on crisscross method, my 2 will now come on the top. So this has to be SO4, 2 minus AQ. Okay. Plus, well, my 2 here comes on the top to give me my charge. So this will be magnesium 2 plus AQ plus, well, we have 2 moles of hydroxide in solution. So we have 2 OH minus, Okay, and then we simply draw our arrow. Okay, so we simply draw an arrow. And then we go to the other side of the equation. So if I look at this, I have 2 moles of H2O liquid plus, well, magnesium will give me what? If I take a look at this, we gotta be very careful here. And this is where I want you to be very careful. We need to know the polyatomic ion charges. And actually, this is magnesium SO2. So look, if I break this up into its constituent parts, this is magnesium 2 plus SO4 2 minus. And so you can see that if we crisscross this, these will actually cancel out to just give us MgSO4. So that's why we need to know the charges on our polyatomic ions. And so in this case, I will actually have magnesium 2 plus AQ plus SO4 2 minus AQ. Okay. And so in this case, this will be the complete ionic equation for this reaction here. Now the net ionic equation. Well, now I'm just simply looking for spectator ions. So I see magnesium and magnesium on the same side, on the right and the left, so that goes to 0. SO4 minus is on the same side, is on 2 of the same side, so that will go to 0. That looks to me as I can't cancel out anything else. So this will give me 2 moles of H plus AQ plus 2 moles of hydroxide minus, and that will give me 2 moles of H2O liquid. And I forgot my subscript. Okay, so notice again, I get water as a complete ionic equation. So this is how we deal with the molecular equation, complete ionic equation, and net ionic equations.